Hello students.
Hello sir.
Welcome to the lecture. Today we are going to see a case study on FEM, right? So in FEM we have seen many lecture videos. So today we are going to see a case study on FEM, right? So this case study is dealing about the FEM application in 3D printing as well as how it is incorporated in medical industry, right? So today's case study is about how a board is replaced. How a bone is replaced. So how to replace a bone? So this bone is damaged. My elbow is damaged, right? So once this elbow is damaged, what they will do? Yes, this is what the discussion. So before into the session, I would like to have your opinion and I would like to have your knowledge on this.
Now today's new technology, we are using FEM and using the 3D printers, 3D modeling for the replacement of bones.
Okay. So how 3D printing or FEM is used? What is FEM? FEM means? What is FEM? Finite Element Methods. Finite Element Methods are FEM means Finite Element Analysis. So this is an analysis tool. So where it is applied? Why it is applied? Right? So because you see the elbow is the strongest part of our body. Do you know that?
Yes, sir.
Yes?
Yes, sir.
Once it is damaged, you will lose your maximum strength, right? So while you have to stand means you use your elbow, your balancing, right? It's one of the strongest bone, right? Once it is damaged, it should be replaced. The replacement should be a biometric implant, right? Because nowadays, the olden days we use titanium inside our bone, right? Titanium is screwed in between the two bones. Imagine this part is missing or this part is crushed or crumpled, right? Because of injury, and this crushed part is removed, and this part and this part is connected by means of a titanium. This titanium at some particular time it may not react, but it is too costly. Whereas now the technology has improved. The 3D printing is one of the technology that is booming in, right? This 3D printing is used, right? Used to print bones, heart, valves, skull, everything, right? So you know about 3D printing, right? You know about FEM. Now in this case you incorporate both and tell how it can be done.
So first, if a person is required arm or a bone for his arm, so first thing is we have to measure his dimensions. So
Good.
what do we want?
Yes.
What is the measurements of his arm and everything? So we have to scan his arm. Using the scan, we can determine the measurements or dimensions of the arm, and then we can design the arm using some designing software like SolidWorks and ANSYS and etc. And we can determine its required shape and size of his arm and the bone. So after doing it, we can incorporate FEM methods to analyze the bone's density and what material can be used for his arm, and all those things using FEM software.
Yes.
Sir, after that, you must want to measure the load, how the load is acting on the bone. Then we must select the material, which material we want to select for the bone, which is not reacted with our body. After that, we can choose the material so that we can implant according to the operation.
Yes, good. As both of them said, so clearly they have stated, right? So once you have to scan, because my elbow is not matching with your elbow because you have a different body dimension, right? Right? And once you scan, very good point that is, you have to scan first. You have to generate the profile. Once the profile is generated, then you will choose the material, right? So that is a biomaterial, right? It should not react. It should not react, as human told, it should not react. So that material should be predicted. Then you have to use FE, that file element. So there you have to model. So how you have to model? It should be a hollow, or it can be a solid, what kind of material, what kind of geometry you can use it for printing. Once it is done, all the thoroughly analyzed through FEM, the results are predicted. Now you can go for the 3D printing. So once it is printed, then we can operate and we can fit inside the missing board. So this is how you have to use the concepts of 3D printing and FEM. So this is what the case. So this is how this medical industry. So what we mechanical engineer, we study number of subjects. These subjects are applied all over the various engineering sciences. So in electrical science we use 3D printing, FEA. In aerospace we use aerospace, the missiles, the rockets, everything we use FEA. The computational fluid dynamics. So everything is studied. Then they go for the manufacturing. So once you have to do some analysis, why do you need to do analysis? Even take a pen, right? Have a pen. We have a pen. Someone have a pen. Give me a pen, right? Yes. See. I have two products in my hand. This product you can see here, the cap. It is with the cap. This product is not with the cap, but the application is same, right? So here analysis is done. So how much force is required to engage this nib, right? If you have a more if you require more force to engage this nib, will you use this pen? You will not use. Similarly, there should be some minimum efforts to close this cap. You have a tick sound at your ears, right? So all these things are analyzed by using some engineering, fine tuning analysis, and then the manufacturers go for that manufacturing. There is one more thing I would like to record in this lecture, that even the Tata Punch and Tata vehicles manufactured earlier in between 22 and 2023. If you press the horn, it is very what we can say, it is very hard and heavy to press the horn. Normally horn we use all the corners and most of the time on the road, am I right? To indicate the presence of the vehicle, right? But the horn that part is manufactured very hard. I have experienced 2023 model, the Punch 2024 model, I don't know the year, but that model, that if I place my hand and if you apply some pressure, the horn is not engaged. I have to use some additional force. That is overcome in 2025 models, right? I have tested. So everything, wherever you go with engineering concept, there and all we use our own studies. That finite element and additive manufacturing, the 3D printing is a very good thing. So by end of this lecture and the discussion, right? So this is how you will replace a LO. So you will design with the FEM and you will analyze with the FEM and then you will produce by using